Right, so in this video, we are going to discuss the in-class exercises. So the questions are shown here on the lower right corner. So the first one, every car registered in Singapore has a license plate number, which begins with the letter S and followed by two other letters, 4 digits, and then another letter. So in this case, we have the letter S followed by two letters, 4 digits, and finally another letter. So how many possible license plate numbers are there? Now, in order for us to generate a license plate number, we need to fill up all the slots here. So essentially, this can be seen as an application of the product rule because we have 7 slots, each of which needs to be filled with a particular choice. Now, it says that the 2 here are letters. Now, how many possibilities are there? So in this case, they're all uppercase, and we are talking about the English language. So the number of letters they are is 26. So 26 letters, we have 26 choices for this slot. So the following is again a letter, so again we have 26 choices. Now the next 4 are digits, and the digits here is from 0 to 9. So if you look at the number of possibilities, it'd be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So essentially there are 10 possible digits, and there are 10 here, 10 here, and 10 here. So the last one is going to be a letter. So again is 26. Now, since we have to fill up all the slots, so it's going to be a direct application of the product rule. So it's going to be 26 to the power of 3 times 10 to the power of 4. Now this is going to be the total number that of license plate numbers that can exist in Singapore. Now the second part of the question says that all plate numbers beginning with SH are for taxis only. How many possible license plate numbers for private car owners? Now there are a few ways of solving this problem, and we're going to be looking at both of them. Now one way is to try to generate only the non-private car, the non-taxi numbers. So in this case, we can imagine that we have the non-taxi would again start with S, and since H is taken by a taxi, so this second spot cannot be an H, but it can be any of the other 25 letters. So in that case, we can fill this up with 25 possible choices. Now, for the other ones, we are going to follow the same logic as before. This one, there are 26 choices because it's again a letter. The next one is a digit, and in fact the next 4 are digits, and finally there is another letter. So then in total, we are going to have 25 times 26 squared times 10 to the power of 4. Now this is a number of license plate numbers for the private car owners. So now this is one way of doing it. Now a different way of considering the problem is that because this is the total, and by the applications of product rule and sum rule together, we can actually see that the total is the same as the taxi plus the private car. Now in this case, we are going to assume that you can either be a taxi or a private car, and you cannot be both of them at the same time. So the total is what we get here before, which is 26 to the power 3 times 10 to the power 4. So this is 26 to the 3 times 10 to the power of 4, and this is equals to the number of taxis. And if you are looking at the number of taxis, taxis is going to start with an SH. So we only need to care about the other two letters here and here, as well as the 4 digits, which is going to be 26 squared times 10 to the power 4 plus the private cars. So then the rest would then be in terms of how we compute this number of the private cars, which is just 26 to the power 3 times 10 to the power 4 minus 26 squared times 10 to the power 4. Alright, so we consider two different ways of solving the second part, which is either to generate the private cars directly, or by computing this equation where we have the total number minus a taxi, we get a private cars. Alright, so that's the first exercise question. So the next exercise question has something to do with the passwords. So it talks about generating different passwords. You're supposed to create a new password, minimum 6 characters and maximum 8 characters. And they can be alphanumeric characters, meaning like letters and numbers, and they are case insensitive, which means that we don't care whether it's uppercase or lowercase. Now the passwords has to contain at least 1 digit. Now how many possible passwords are there? So in this case, we are going to consider how to generate the passwords, and since it says that it can be 6 to 8 characters, so now we're going to first assume that we're going to generate the 6 first. Now to generate the 6, so there's going to be 6 slots for the characters that we need to fill in. And it says that it's alphanumeric characters, letters and numbers, case insensitive, but the password has contained at least 1 digit. Okay, now if it can be any one of them that is a letter or a digit, so essentially there are 26 letters plus 10 digits, so each one here is going to have 36 possible choices. Right, so if we do this, then we're going to get 36 to the power 6. Now, but it must have at least 1 digit. Now, how are we going to get the answer to this? So we can again use a combination of product rule and sum rule, and all possible passwords is going to be the same as a password with no digits plus the password with at least 1 digit. So we already have here the number of all possible passwords, which is 36 to the power 6. These are the possible passwords of length 6. Now we can also compute the number of passwords with no digit. It means that simply that such a password is going to contain all letters. If it's going to contain all letters, then in every slot we're going to have only 26 choices. So then we're going to have 26 to the power 6. And then this number that we are looking for will essentially just be 36 to the power 6 minus 26 to the power 6. So this is the answer for 6 character passwords, but it can be 6 to 8. So in that case we need to consider the 7 character passwords as well as the 8 character password. Okay, the sum of these 3 numbers would then be the answer to the first part of the question. Now the second question here on the lower end essentially asks now that the passwords may contain lowercase letters and digits. So in this case essentially it's still case insensitive too. Now, how many 6-character passwords can start with the lowercase letter a or ends with the lowercase letter z? So now we're just going to look at the ones that first start with the letter A. So essentially we have A here. If it's A and it's 6 characters, so we have 6 slots. Now in this case, because it's again lowercase letters and digits, so these are the possibilities. So we have 36 in every possible slot. 26 are for the letters and 10 are for the digits. Right? And we can also look at the passwords that is going to end with the letter Z. So in this case, again, there is 26 in every possible slot. So in total, we can have 26 to the power of 5. Now, do we have any double counting here? So what is double counting? Double counting is a case when something is included here, but it is also included here. And the answer is yes, right? So which ones are double counted? So the one that is going to be double counted are the ones that are essentially starting with A and at the same time ending with Z. So in this case, we have 36, 36, and 36 here. So then what is the number that we are looking for? It will be the number of passwords that start with A and the number of passwords that start with Z, end with Z, and at the same time we're going to be remove the ones that are actually double counted. So in that case, the total number is going to be 36 to the power 6, which is coming from the first row. I'm sorry, not 6. 36 to the power 5, which is coming from the first row, plus 36 to the power 5, which is coming from the second row. This is the password that ends with Z. And then we're going to be removing the ones that are double counted, which is this side, which is 36 to the power of 4. Alright, so this is the answer.